right? Now, the other thing that we want to look at is what if we pass in a double double? So 7.5, 7.8.5, 7.5, and we run this. Let me go ahead and close this. So this is now a double double. So that is a case like u, t, and u are the same. So let's run this and see what happens. Right, so 7.5. And we run this and we get 16. Right, let me change it in a way that 7.8, we can see what exactly is happening. So I run this and we get 16.3, right? So a double was returned over here. So we had a double double. So T was a double and U was a double as well. So it was auto detected that the first number is a double. So double was assigned here and double was assigned here as well. And then here is a double, so there was no problem. The double was returned. Now in this case that we had a double here and then an integer, right? We had double t as a double and u as an integer, so a double was assigned here and an integer was, and a double as well was assigned here. Now in a case that this place is an integer, we're going to have an integer value returned as we saw in the as we saw previously. So when we run this, we're going to get an integer value return because 7 is an integer and is going to get assigned to the sum to be an integer and is going to return an integer. But what if, so we see an integer returning. What if we are using the template and we don't really get to know the order of data types that we should use? What if we don't know that? Then that means that we have to always come back and check what the order of passing the parameters should be, right? So that's not what we want. So what we want to do over here is to explicitly say that the function should always be of this particular data type, right? So we want to create a third class so that a third class, a class C, let's just say, so TUC, we just have that. I think they rhyme. So what we want to do over here is we want the first parameter that will be declaring to be for the function and it's going to return that particular data type. And we want the first one to be of type U and want the second one to be C, right? Okay, so when we come to call the function, then we'll have to pass in this parameter. When we don't pass it like before, when we don't pass it like before and we run it, see what's going to happen. We get an error that no matching function, right? We don't have a matching function. Why don't we have a matching function? Over here, the function is to accept 3 parameters, right? It's going to accept 3 data types. First data type U, T, second U, and third C. But over here, we did not pass anything. Now, this data type is of integer and this is of double, right? Over here, this is of integer and this is of double. And this is going to be a different one totally from this one. If we had put U here, then U would automatically get assigned. But this is a different one, T. So that means for this particular one, we have to explicitly state over here that we want to use a double for this particular one, right? So in that case, whether we use an integer here or double, or we reverse it and use double integer, it's still going to work the same because this is different. This is totally independent from these ones, right? So for these ones, we don't need to declare their data types in the parameters, even though we can do it like double, double. No, this is a double int double. So for this one, for the remaining two, there is no particular order of calling. You can say double int or int double. It really doesn't matter. But the arguments we're passing here are of int and double. So let's go ahead and run this to see the output. Now we have 15.5. We have a double returned because we explicitly stated here that T is going to be for double and we used a double over here. Even if we clear these ones, it really will not matter, right? So we can, if we run this, we're going to get 15.5 again, right? So we can even change these parameters like 8.5 and then 7 over here and we're still going to get a double, unlike previously when we changed and we were getting either a double or an integer, right? So over here we are getting the same answer because we have created a different class for the function and its return. So we have 15.5 now. So anytime you call the double function using the its template, you can either pass in a double int or an int double, and you'll still have a similar value returned every time, right? So what if we want to pass in a string? So over here we have to use the string class because it we have to explicitly state over here. Now the second thing we want to do is, let's say we don't declare that this is going to be a string, but yet we go ahead and then we put in string parameter, string argument. So let's say hello, and then over here we put in world. So hello world. Let me go ahead and put the space over here with an exclamation mark. Let's go ahead and run this and see what the output is going to be. And now we have an error over here that invalid operand of type constant character and constant character, right? The auto deduction works mostly in, as I've stated here, in this specific case, the compiler can auto deduct the type without explicitly defining it. In this specific case, that's for integers. Now we can't use the auto deduction. We have to explicitly pass it in. So we have to say that these arguments are string and string. Right, so they're all strings now. So T is string, U is string, and C is string. So we just run this and we should be getting a hello world. Right, now we have a hello world over here. Right, so for this one, when you're using strings and you want to use the template, you want to explicitly state it. You don't want to auto deduct because it's going to throw an error. Right, so those were the different forms of combining these ones. So now let's see if anything is left in the notes. In the case of three template parameters, three parameters should be passed, but right, good. So is the type in some cases it might even be a limitation, right? So let's go back to the previous example where we were using double. The function was double, and then we declared an int and then an int, sorry, and then a double, right? So what if we come in here and then mistakenly pass in, the first one should be an int. So what if we mistakenly pass in a double? Let's say 4.5, 4.6, and then over here we pass in an integer. Even though this is a double as well, this is not an integer over here. So let's run this and see what will happen. So take note that whole numbers are equally doubles. You can use them like doubles, but you can never use decimated numbers as integers. So right now we have 11 returned as an answer, right? So but we know 4.6 plus 7, it's never 11. There should be a decimal point somewhere. Now what happened here is that we declared explicitly here that this is going to be an integer. So the value 4 was taken, 4.6 was broken down to an integer, so 4 was returned. So this is equal to passing in 4 over here. So when you pass in a double over here, but then mistakenly use an integer class over here, right? Then what happens is this one gets broken down to an integer, and then it takes it as an integer and then works with the value like an integer. So it is advisable for me, as this is just advice from me, right? So you just do not explicitly define them here. If you are using three parameters in this case, do not explicitly state it because you might run into errors. Just create a template to have classes like this such that you can easily interchange the classes. So whatever class comes first, it really doesn't matter. So you can bring in integer double or double integer. Since the returning value is going to be, you have created a different uh, class for that one as well, then you wouldn't have any problem. So let's go ahead and run this. And now we have 11.6 returned, right? Because it was auto deduction. but you can explicitly state it as well, but you have to be very careful. So that is it for that one. And non-type template arguments. So right now we're coming to look at non-type template arguments. So go ahead and comment out all of these. Right, so what are they? And these ones can be expressions. So what we created over here, I'm just going to go ahead and use this example to illustrate this concept as well. So I'll just come up here and copy it and then paste it over here. Now, the concept of templates is to have a ready structure that you can just tweak something and the functionality is being adapted to whatever you want to use it for. So in this case, when you use the class T means that T is going to be of a data type that you will be changing. So that's why we're just changing data types, data types, data types, data types. Now you can accept in, expressions into the template parameters that you might want to be changing, right? So over here, we just create an expression, let's say int a. We have created a fourth parameter over here that the function will be accepting, that we can change in other functions. So nothing has changed so far, nothing has changed over here. We just added a fourth parameter that the function would be accepted. So when we come to call the function, we would want to explicitly state here as well that now the order of parameters is T, T, C, A. Now, what if I pass in the fourth one is going to be an integer, right? So I just pass in 7 over here. Now, when I pass in the 7, what is this integer going to do? We forgot to include it in the code. So what we just want to do over here is, let's say we just want to multiply this result by we just want to multiply this result by the integer, that particular integer, right? So this is going to be a times whatever result that we'll be having, right? So this is the new updated code that we have over here. Now when we pass in this integer as a parameter, because we have created room for it over here, right? So what this means is that I can create several of these. So let me just copy and paste over here, and then I can change these ones to, let's say, 6 and 5.5, anything. So I can create these ones, and this one will be repeatedly used to multiply with these parameters. So let's go ahead and run this to see what the output is going to be. And we have an error thrown over here that no matching function called to sum, right? So now, as we can see, we have 4 parameters here and they are accepted in order. So we passed in double and we passed in 7. So the 7 was taken as class U, right? So the second parameter that we should have passed here should have been a data type and not of integer. So let's go ahead and then input double, and the last one is int, right? And then we then have a 7 over here. Then we want to input an int because the 6 is an int, and then the 5.5 is a double, right? So over here we are explicitly stating it. Now we go ahead and run it, and now we have 81.8, and then this one I should put an end line statement over here to separate them. End line, right? So we rerun this again, and now we have 81.2 and 80.5, right? So this template accepts 4 parameters, so we would want to declare 4 parameters in order of their occurrence. What if we don't want to pass these 2 parameters? Because passing them, we'll have to be careful to look at what argument we are passing and what data type. So in order to avoid that, we can copy this, we can cut it, and then paste it as the second parameter, so that we just declare the data type for the function, and then these ones would be auto deducted. So what we can do over here, we brought it as the second parameter, so the 7 can then be substituted over here as a second parameter, and we do not need to explicitly state these ones. So when we run it, we should be getting the same output as before. And now we have the same output as before, 81.2 and 80.5, right? So this is how to use expressions as arguments and not just data types. So if you want to be changing these ones that you want to be using, now you might have noticed that we could have passed this as as a parameter to the function and not to the template, right? You can do this. And when I checked from the C++ website, it says the same thing, that you can do this actually, but then there was something that was said, but I really did not get to understand what exactly it meant. It said over here that there is this a major difference. The value of the template parameters is determined on compile time to generate a different instantiation of the function fixed multiply. So they used a different function over here, and I just use um, something else to explain to you guys. And that is the value of that argument is never passed during runtime. I really do not get to understand this, but I don't want to leave anything out, so I just included it for you guys. Guys, I really hope this video was helpful and you really did get something out of it. Stay safe and hope to see you in the next tutorial.